Hello dear students, welcome to a new math session. Today we'll be talking about comparing and ordering rational numbers. The first thing, we'll be talking about comparing two fractions that have common denominators. Like here, 3 over 5 and 1 over 5. If the two denominators are the same, you decide according to the numerator. The 3 is bigger than the 1. And if it's negative, take care. The negative 3 is less than the negative 1. The second thing, comparing two fractions with common numerators. If the numerators are the same, then the bigger the denominator, the smaller the value. So here in the first one, the denominator is 2 and the denominator is 3. So the denominator that has 2 is more than the denominator that has 3. Example 2, 2 over 5 is less than 2 over 3. Here, again, the bigger the denominator, the smaller the value. So 5 is bigger than the 3, so the value is less than the 3. So 2 over 5 is less than 2 over 3. And there's also another way that we can use in any of the examples. Let's apply it, for example, in example 2. The 2 over 5 and the 2 over 3. We multiply diagonally. 2 times 3. 2 times 3 is 6. We multiply diagonally. 2 times 5. 2 times 5 is 10. Which is bigger? The 10 is bigger than the 3. So you take this sign, it goes up here. And you can apply this way whenever you're comparing any of the fractions. The third comparison is comparing two fractions with denominators. Like, for example, 2 over 3 and 5 over 7. Here, the denominators are different, the numerators are different. So you have two options. Either to make them having the same denominator, like by multiplying the left fraction up and down by 7 and the right fraction up and down by 3. So it will be 14 over 21 and 15 over 21. Which is bigger? The 15 over 21 is bigger than the 14 over 21. How about trying our other way? In the other way, we multiply diagonally. 2 times 7. 2 times 7 is 14. We multiply diagonally. 5 times 3. 5 times 3 is 15. For sure, the 15 is bigger than the 14. Fourth, comparing two rational numbers in decimal forms. For example, 2, 3 over 4 is a mixed number, and 2.14. What's easier for you? Yes, the 2 and 3 over 4, I can change it into decimal to be as 2.75. So we can compare 2.75 and 2.14. So for sure, the 2.75 is bigger. Example 2, 1.3 and 1 and 1/3. 1 and 1/3 is 1.3333, and the 1.3, so for sure, the 1.333 is bigger than the 1.30000. Let's go to exercise number 1. Put the right symbol, whether it's greater than, less than, or equal. Question 1. The 1 over 4 and the 1 over 6. Uppers are the same, so lowers, the bigger, the smaller. So 1 over 4 is greater than 1 over 6. Or you can do it by the scissors way as I taught you. Question 2. Negative 5 over 7 and negative 3 over 2. So negative 5 over 7 is bigger than the negative 3 over 2. 9 over 5 and 1 and 2/3. So in this one, we can make it as 9 over 5. And here, if you change this mixed number into a fraction, it will be 5 over 3. If you multiply the diagonals, 9 times 3, this is 27. And 5 times 5, this is 25. So the 27 is more than the 25. So this fraction is more than the other fraction. Change this also into a fraction. It's negative 7 over 2. And here it's negative 20 over 6. Negative 7 times 6, that's a negative 42. Negative 20 times 2, that's a negative 40. Which is bigger? Take care, it's a negative sign. So the right fraction is bigger than the left fraction. Half and 2 over 8. As you can see, the 2 over 8 is 1 over 4, where the half is 1 over 2. Or actually, logically, what's bigger, a half or a quarter? So it is the half. So 0.5 is greater than 2 over 8. Question 6. 1.6, an absolute value of negative 8 over 5. The absolute value of negative 8 over 5 is a positive 8 over 5, which is 1.6. So they're equal to each other. Exercise number 2, arrange the following numbers in descending order. So how to arrange them in descending order? The easiest way for you is to make them all having the same denominator. So when the question asks me to arrange, they all should have the same denominator. So let's make it a common denominator for them all, which is 30. So here in this one, we're going to multiply up and down by 3. So it's 9 over 30. This one is already over 30. Here, we're going to multiply up and down by 10. So it's negative 10 over 30. Then multiply here up and down by 6. So it's negative 6 over 30. And then the last one, multiply here up and down by 2. So this is 8 over 30. And descending order means from bigger to smaller. So the biggest is 9 over 30. This is number 1. And then this is number 2. This is number 3. This is number 4. And this is number 5. But take care when you arrange the original numbers in the question. So this is the first one. It's 3 over 10. And then this is the second one, which is 4 over 15. After this, it's 7 over 30. After that, it's negative 1 over 5. Last one is negative 1 over 3. Exercise number 3. Arrange the following numbers in ascending order. Ascending order means from smaller to bigger. As we said, that they all should have the same denominator. Here, the denominator common will be 24, so we multiply this up and down by 6. It will be 18 over 24. We multiply here up and down by 3. It will be negative 15 over 24. After that, we multiply here up and down by 2. It's negative 14 over 24. And the last one, we multiply up and down by 8. So it's 16 over 24. Ascending order, as we said, from smallest to biggest. So this is number 1, this is number 2, this is number 3, and this one is number 4. So number 1 is the negative 5 over 8. Number 2 is the negative 7 over 12. Number 3 is the 2 over 3. And then the last one is the 3 over 4. Exercise 4. Find 3 rational numbers lying between 2/3 and 3/5. How can we do this? We're going to put the two numbers at the common denominator, 15 and 15. So we multiply the first fraction by 5 up and down, and the second fraction by 3 up and down. So it's 10 over 15 and 9 over 15. Here, you cannot have any numbers in between, right? Yes. So we multiply the two terms by 4 up and down. So it's 40 over 60 and 36 over 60. So we can easily find the three terms in between, 37 over 60, 38 over 60 and 39 over 60. What is the density of the rational numbers? Between any two rational numbers, there are infinite number of rational numbers lying between them. Now let's go to the evaluation part. Please pause the video, try to answer the questions yourself, and then play the video again to check the answers. Question 1, 2/3 and 1/3. For sure, 2/3 is bigger than the 1/3. Question 2, 4 over 5 and 3 over 5. 4 over 5 is bigger than the 3 over 5. Question 3, 4 over 9 and the 1. For sure, the 1 is bigger than the 4 over 9. Question 5, 2/3 and 4/5. How do you do this? We can do the diagonal part. 2 times the 5, it's 10. 4 times the 3, it's the 12. So the 12 is bigger than the 10. So 2/3 is less than the 4 over 5. Question 6, the half and the 0. For sure, the half is bigger than the 0. Question 7, negative half and 0. For sure, the 0 is bigger than the negative half. Question 9, negative 4 and half and the negative 5. For sure, negative 4 and half is bigger than the negative 5. 4 and half and 5. 4 and half is less than the 5. And for the absolute values, the negative 15 over 2 in the absolute value is 7 and 1 over 2. So they are equal to each other. Write two rational numbers lying between 1 over 2 and 4 over 10. If you first make it with a common denominator, we multiply here up and down by 5, and we multiply here up and down by 2. So it will be 5 over 10, and this will be 8 over 10. So how can we get the two rational numbers in between? So they are the 6 over 10 and the 7 over 10. Now, dear students, we came to the end of our session. Thank you very much and wishing you best of luck.